Welcome, student, to the connectivity, where we will study the shape of the function and how much it curves when we sketch the function. In the beginning, I would like to focus only on increasing function. And if you know, increasing function has three different ways where the function increase. Suppose I will move from this point to this point. I could move directly in a straight line. Also, I can move in a curve going like this. And the third case, I can go like in a different way of curve, like this one. So I have three different ways where I can connect those 2 points. Either straight line, which means has no curvature. It doesn't turn, it's like a straight line. You can do this, where you can just go like this. And this is, if you can see, it's concave upward. If you just try to imagine how the function goes, it goes upward like this. And the last thing is concave downward, which means it's like this. Concave downward. This is if we have the, of course, concave upward, usually we write it as CU, concave downward, we write it as CD. Now, of course, you can imagine if somebody is standing on this curve, he's like looking upward, but if he's standing on this curve, he's looking like downward. So those are the three cases. And now the question is, how do I tell which case of these is going on? The answer is very simple, and we have seen similar thing before. Just look at the second derivative. The second derivative is positive, we have concave upward. The second derivative is negative, we have concave downward. The second derivative is 0, we have no curvature, which is straight line. So if I go back to the previous picture, all what we have here is, here we'll have the second derivative is 0. Here we have the second derivative is positive. And here we have the second derivative is less than 0. So that's the only way we can find which function in which case. Finally, we have a point of inflection, and this is similar to something we have seen before. We call it critical numbers. But critical numbers, we focus on the first derivative. Inflection, we focus on the second derivative. And what does it mean, inflection point? Inflection point means you move from one. Now, if this is inflection point, it means I change the way I curve. For example, if I go upward, at this point, I go downward. It has a change in the curvature. That's the inflection point. Usually we abbreviate it by IP. So we have going concave upward, and then we go concave downward, and that's exactly what we get as inflection point, which we focus on the second derivative. We will see now a couple of examples where we find the concave upward, downward, and the inflection. Welcome, student, to example number 1, where we need to discuss the following curve with respect to concavity. Concavity means either it's concave upward or we check if it is concave downward. Remember, concave upward, it means the curve will go like this. Concave downward, it means the curve going toward down. This is concave downward and this is concave upward. And we need also to find the inflection point. And remember, the inflection point is we focus on the second derivative. It is either 0 or the second derivative does not exist. So we need to check which one of these is the inflection point. So in this question, what we need to do, first step, we need to find the first derivative, which will give me just 3x squared. And most importantly for me is the second derivative, which will be just 6x. Next step, we need to find the inflection point. So just let me write it down. We need to find the inflection point. And remember, in order to find the inflection point, we need either to find where the derivative is either equal to 0, or if the derivative has any problem which will make it does not exist. Remember, we have a problem. Most of the cases will be if we have a denominator. So this is not happening here. The reason why we don't have any problem with this function, in particular, if we go similar to what we did, there is no denominator. So this case will not be useful to me. So only I'll focus here. Now, second derivative is just 6x. So I will make 6x equal to 0. That means x equal to 0. And this is not the inflection point. This is a candidate to the inflection point. So what we need to do next is we need to know if it is concave upward or downward. And to do that, we will do the number line. We will put 0 here. And then we will check the sign of the second derivative. If it's a plus, it means it's concave upward. If it is a minus, it means downward, and vice versa. So the next step, I will draw the number line as we did before. Here, I'll put x equal to 0, and just let me remind you of the derivative of the second derivative. It was just 6x. And now we ask ourselves, what is the sign of the second derivative? So we take a test point here. I will take 1, and I will plug it here. So if you plug in 1, the answer is 6, which is positive. So everything here will be positive. So in this area, we have just what we need it to be. It is all positive, which means it is going upward, which means it's concave upward. Now, take another test point here, which is -2, for example, and find the sign of f double prime, which means take this x and write it -2. Now, 6 times -2, this is -12. -12 is definitely less than 0, so everything here is negative, which means concave downward. So in this case, here we have negative, 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 which means concave downward. Now what happened is I have concave upward and then I have concave downward. So definitely this point here is inflection point. So we have inflection point because it changed from positive to negative at x equal to 0. So if we write the summary, concave upward, we have it from 0 to infinity. Concave downward, we have it from -infinity to 0. And finally, inflection point, sometimes we just write I dot P, is going to be the point which has x comma y. The x will be 0, and we need to find what is the y. And how to find the y? We go to the original function, we substitute x equal to 0. The final answer just 0. So we get 0, 0 is inflection point. So this is how we find the concave downward, upward, which is, I'm sure you can relate, it is much similar to what we did with increasing and decreasing. So it was increasing, decreasing, and local maximum, minimum. Same story we do all again, but this time with the second derivative. Let me show you another example where we will need to find concave upward and downward, and this time we have a different function, which is f of x equal 2 plus ln x. So the first step is to find the first derivative. So the first derivative of 2 is 0, Now, derivative of ln x, if you will focus more on this later, but derivative of ln of x is just 1 over x. So here we'll just get 1 over x. And now I want you to find the second derivative, which will be negative 1 over x squared. Next step, we need to do two cases here. Either the second derivative does not exist, so it means we have a problem, whether it's denominator or something else, or we have the second derivative equal to 0. Now, because I have numerator and I have denominator, I will get the numerator equal to 0, but this has no solution. Why it has no solution? Because the numerator is just negative 1, and negative 1 will never be equal to 0, so this case is useless to me. I need just to focus on the second case. Now for the second case, since we have denominator, we make the denominator equal to 0. That means x squared equal to 0, which will give you just x equal to 0. Next step, we just need to put this in the number line and check the sign of f double prime and see what we are gonna get. So what we will do next is we will put the 0 here, and then we will see if this is positive or this is negative, concave upward, concave downward, and so on. So put the number line. That's the number line. We write 0 here. And remember, we need to find the sign of f double prime of x, which is negative 1 over x squared. Now, if we do that correctly, we need to take a test number, substitute x equal to 1. This will be just all negative. Take any number here, for example, minus 2. If you substitute it, this will be also negative, which means this is concave downward, which is go down, and it goes down. Which means concave upward, nothing, we don't have, so we just write it as empty set. Concave downward, you start from negative infinity to 0, and then you continue from 0 to infinity. What is between them is a union, and we have no inflection point. Why we don't have an inflection point? Because we don't have an inflection point because there is no concave upward and then concave downward. And that's what we get here for this question. Let me do final question, which is part C, and we'll go through the same similar steps as we just did. So the first step, you find the first derivative. Derivative of x power 4 is 4x3 minus 9x squared plus 4x. And then we find the second derivative, which will give me 12x squared negative 18x plus 4. That's what we get here. Now we need to find two cases here. Either the second derivative does not exist, which means this never happens. This is not happening. And the reason why, we don't have denominator. Now, the next one is we need to write f double prime of x equal to 0, which means what we are going to do is we need to write 12x squared minus 18x plus 4 equal to 0. And here we need to solve it by mod 5(3), or we will use the quadratic formula. So if you use the quadratic formula, we will get here we will get 4 times 4 times. If we do it with the quadratic formula, we will get two numbers for x. It will be 18 plus minus square root of 132 divided by 24. So if we find the approximate value for x, it will be approximately 1.22, and the other x will be 0.27. Now, what we need to do next is we need to write the number line and check whether it is concave upward or concave downward. So here is the number line. And now we need to find the sign of f double prime of x. Remember, f double prime of x, because I will need it to substitute, it is 12x squared minus 18x plus 4. Now you have two numbers. One of them is 1.22, which is, of course, this is the approximation. So I will put the sign of the approximation. The actual number should be here, 18 plus square root 132 over 24. And then you have another number, which is 0.22, which is the approximation of 18 minus square 132 divided by 24. And now all what you need to do is just, we do it with the same thing. So we get here plus, 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 and in the middle we will get negative. So the concave upward will be from negative infinity to 18 negative 132 divided by 24, and then you continue from the other number to infinity, and you write a union. Concave downward, it will be just from those two numbers. And then we have inflection point. This is concave upward, concave downward, concave upward. And we have two inflection points, which be exactly the following. What are the inflection point? It will be 18, 132 divided by 24. This is the value for x. All what you need is to use your calculator to find the value for the y. This is one inflection point. The second inflection point is 18 plus square 132 divided by 24, and then find the value